Alright, welcome back everybody. Again, talking about electric fields, but this time with a different formula to learn more about electric field. Alright, so a few things. When a charge enters an electric field, there will be a force. So we're going to be talking a little bit more about this during this part of the slideshow. Positive charge will go in the same direction as the charge, while negative direction will go in the opposite direction of the electric field. This lowercase q is the charge within the electric field. So for example, this big Q is the one creating the electric field. This little q is going to be the test charge within the electric field feeling a force from the electric field. E is the electric field, F sub E is the force of electricity. Here's the main formula. And then these are the other formulas that you get when you algebraically manipulate them. Alright, moving on. So, example number 18, conceptual example. What direction is the force of electricity for the positive particle in the diagram? So remember, the electric field at this point is going to be going this way. And since it's positive means the force of electricity is going to go in the same direction as the electric field. So it should be C. Example number 19. What direction is the force of electricity for the positive particle in the diagram? Okay, so since this is a negative charge, what this means is that it's going to be emitting an electric field going towards it. Meaning, in this case, for that charge, the electric field is going to be going in that angle. But since this is a positive charge, it goes in the same direction as the electric field. So the force of electricity will be the same. So it should be C. Alright, conceptual example number 20. What direction is the force of electricity for the negative particle in the diagram? So like I said, at this point over here, since it's a negative source charge, it's going to be going towards it. Okay, this is electric field. And since this is a negative charges go in the opposite direction of the electric field. So the force of electricity is going to go over here. So it should look like that. And the answer is going to be B. Alright, moving on. An electric field is in a region of space. A particle that has a negative charge of negative 0.7 coulombs, experiencing a force of 240 newtons. Let me just write some things down. 0.7 coulomb. This is 240 newtons. Find the magnitude and direction of the electric field. Force. Electric force. Find the magnitude and direction of the electric field. Okay. Electric field is going to be equal to Fe divided by Q. So where does this come from? If we look way back, we have this formula that we said from the beginning. Okay, so let's go back. So find the magnitude of the electric direction. So we'll just plug something in. The force of electricity is 240. And the charge is 0.7 coulombs. Oops, sorry. So this is going to give us 240 divided by 0.7. 342.86 Newton per coulomb. Okay. And we know that it's going to be going to the right because if this negative charge is going to the left, that means the electric field has to be going in the opposite direction, to the right. Okay, moving on. An electric field has a magnitude of 700 Newton per coulomb and is going to the right direction. Find the magnitude and direction of the force this field exerts on a charge of positive 0.2 coulombs, 0.2 coulombs, positive, and negative 0.4 coulombs. Okay, so we're looking for the force this time. Okay, so electric field is equal to the force of electricity divided by Q. This time we're looking for force. So force of electricity is equal to electric field times Q. Okay. Alright, so let's use that to figure this out. Part A. So the force of electricity for part A is going to be equal to the electric field, which is 700 Newton per coulomb, times the charge, which is 0.2. So that is going to be 700 times 0.2, 140 newtons. And this, since it's a positive charge, it's going to go in the same direction, meaning it's going to the right. Okay. Part B. Part B, similar thing. Part B is going to be, we're looking for the force of electricity of charge B. And the electric field, again, is equal to 700. And the charge is equal to 0.4. So 700 times 0.4, and we get 280 newtons. And we should know that this is going to be going to the left because it's negative, and negative charges go in the opposite direction of the electric field. Okay, that one might be a little tricky. Watch it again if you need to. Moving on. Two charged particles are near a large charge that is creating a significant electric field. They are both the same distance from the large charge and both experience an electric field of 850 Newton per coulomb. The positive charge experiences a force with a magnitude of 220 newtons. The negative experiences a force charge with a magnitude of 340 newtons. What is the charge of the positive particle? Okay. So electric field is equal to Q divided by Fe. Oh, sorry, not Q divided by Fe, sorry. It's equal to Fe divided by Q. So now we're trying to find what Q is. So Q is equal to the force of electricity divided by E when we do some algebra. Okay, so now that we have the formula or the equation, let's figure this out. We can find the charge of the positive one because we know the force. They both experience the positive charge experiences a force of 220 newtons. So it's going to be 220 divided by the electric field, which is 850 Newton per coulomb. Okay, so let's see what this is. 220 divided by 850, and we get 0.26. And it's positive because, well, it says it's a positive charge. All right, part B. Part B, we have the charge, the negative charge, is equal to the force of electricity divided by the electric field. So the force of electricity is equal to 340 divided by the electric field, which is again 850. And what is this? 340 divided by 850. And that's going to be 0.4 negative, because it tells us it's negative. Okay. All right. Hope that was okay. Hope it wasn't too tricky. Next time we're going to be talking about net electric field, which is kind of like the superposition of electric fields. So hope to see you with that. Thanks for watching, everyone. Bye.